Hello, how's everyone doing today? It's good to see you. Let's get started here. I'm going to talk to you today about generating API client libraries. My name is Jordan Adler. I'm the head of developer engineering at OneSignal, and I'm available online. Apparently, you can find me there. I work for a company called OneSignal. OneSignal is basically a customer engagement platform. So we're a component in your application that helps you do push notifications, SMS, email, in-app messaging, but with a focus on customer engagement. So thinking about acquisition, retention, re-engagement, resurrection, users stopped using the app a few years ago, how do you help bring them back in? So we're kind of a marketing tool for your users that's kind of outside the advertising space and built on optimizing customer communication, which is an important part of the talk. It's not just a plug. Can you guys see this okay? It's kind of hard. But basically, we started as push notifications. So we did mobile and web push notifications, then we added in-app messaging. And then later, kind of a few years ago, we added email and SMS as functionality that we support, new kinds of communication channels. Do you want to? And the thing that's different about these two new channels, email and SMS versus push and in-app, is that the point of integration as a vendor with our customers is different. So with mobile and web push, it's going to be very much your front end is doing the communication. And with email and SMS, it's very much the back end. So we make a way for your Android app to send an email, but really it sends a call to your back end to send the email, right? It's just a different kind of integration point. In other words, our customer on the back end, they'll typically communicate to our API server, and then our SDKs over here will communicate also to our API server. And so in this way, we have kind of two different touch points for software developers that build with our tools. And we provide SDKs for these two different touch points, and the goal being that it simplifies implementation. It lets you get there quicker. It handles complex domain-specific logic. So for push notifications specifically, there's a lot of stuff you have to write in your iOS app to make push notifications work, and our SDK gets that stuff out of the way for you. It does other stuff too. It adds other functionality, but there is complex domain-specific logic in our client-side SDKs, less so on our server-side ones. And so, okay, here we go. So if you're looking at these channels, again, these top ones, those are going to be more client-side. These bottom ones are more server-side integration points. And a couple of years ago, we had quite a few client SDKs. We still do. We have a lot of them. Actually, we have a large number of SDKs. And then we had none on the server side. And so we started thinking about, okay, well, if we're going to make some server-side SDKs to help people build with our tools, we want to set some requirements, some goals, to think about how we want to achieve that. And the first goal was very much cover top languages as quickly as possible. We identified the 10 top languages we wanted to do, and so we wanted to build 10 new API client libraries for our server side to serve as the base for our server-side SDKs. We also wanted to make sure we could keep those SDKs up to date as the APIs changed. We expect rapid iteration on our APIs. And ideally, we wanted to build SDKs without requiring any change to our APIs, right? And there's a lot of weird nuances to the way our APIs work because we didn't really build them from first principles. We kind of built them as we needed them, right? I think we all have done this. You have some task and you think, okay, well, how am I going to build this new feature? What's the least amount of work I can do to build a new feature? And so you tack on some code and it's not quite good, but it works. And then you do that 10, 15 times, and suddenly your code is like a complete mess, right? It's not consistent. There's lots of gaps and there's issues. And that was true for our API. And so we realized that we had a lot of technical debt in our API that we did not want to pay down as part of our development of server-side SDKs. We wanted to make sure each SDK was maximally idiomatic. In other words, the Rust SDK feels like it's for Rust developers. The PHP SDK feels like PHP. You're not writing Python that feels like it was built by a Java developer, right? That's not quite the experience people want. We want to provide an idiomatic experience. And of course, we want to leverage and contribute back to the open source communities we love. We're big supporters of open source at OneSignal. We're a very small, early stage startup, and yet, we sponsor to the tune of a few $100s a month open source projects, which is more than many large companies do. And okay, I know what you're thinking. You guys, might as well start asking for unicorns and ponies and all this other shit, because there's no way you're going to get all this. It's not possible. But it is. There's a technique that's built on top of an OpenAPI specification in particular that we decided to take. And an OpenAPI specification is a kind of description, a standardized description of a REST API built in YAML or JSON file that fits a certain kind of format and enables computer systems to understand what an API does enough to be able to take action on that. You may have formerly called this Swagger. I don't know if you guys, does anyone know Swagger? You know Swagger? Okay. Well, Swagger changed their name. It's a long story. I'm not going to get into it, but there was some, essentially the short version is there was a company that acquired Swagger, and then the open source project kind of diverged. And anyways, so basically there's Swagger. The tool became OpenAPI, the specification format, but also OpenAPI generator, the tool. And then there's still like Swagger UI and Swagger tools like Swagger CodeGen. Those still exist through SmartBear, which is the company that acquired it. And like I said, OpenAPI Spec is one of a number of interface design languages. So these are different REST ones. There are other non-RESTful interface design languages. For example, if you're doing RPC calls with like Thrift, that's going to be, well, I guess Thrift is the IDL. Well, there's multiple IDLs in Thrift, but anyways, there are multiple IDLs that you could choose to use here. OpenAPI Spec is one of the newer ones. It builds off of the wisdom and mistakes that we made with WAML and WSDL and RSDL and all those things we've been doing to try and understand and make this space more manageable for the past few decades. And the magic of this system, this technique, is that you can take your spec file and you can take a tool like Swagger CodeGen, like OpenAPI Generator, like Microsoft's new Kyoto, and build out Ruby, PHP, Python, Perl, Dart, all sorts of different languages programmatically for fairly standardized API calls. It's magic. It is the unicorn, right? We have, this technique is the unicorn that gets us there. Okay, so how is the sausage made? How do you build a specification? If this slide doesn't make you cringe, I don't know what will. So the next 20 minutes or so is going to be YAML. So if you want to leave, go ahead and do that now. But you can see here, this is a very small API YAML file. There's multiple blocks that we'll kind of walk through. And this first one is just kind of an info and servers block. You're talking about what's the specification version you're using, where is the endpoint located, how do you contact the people who run it, what's the license, and what does it do. And then here's where you get into like the meaningful bits. So the next thing is security scheme. This talks about the authentication model required to communicate with that API. And now this is the really interesting stuff. So you build out essentially schemas and endpoints. So we'll talk about schemas here. And so schemas are pretty much just model objects, right? They're, you might have a product object, which is a type of object, which is kind of like a dictionary, a Python dictionary. Your ID is required, and then you list out the different properties, and they're implicitly optional. And you can specify it's read-only or write-only, meaning if it's read-only, when I send a put or a post, I'm not sending that. But if I'm doing a get, then I'm getting it. And if it's write-only, it's the other way around. And most things, they can do both. So here's an example of an array. Let's say you have a products object, get fetch products that returns an array of product objects. So you can kind of build on top of the schemas using this kind of $ referencing mechanism. So here's an endpoint. So you have this pass block. Here's an example of a get a list. So get a list of products, and you pass in to the products. There should be a tab over here between products and get. But you pass in a products block, which is like a path block, and then get, which specifies the operation, and then you specify an operation ID, get products. As an aside, that operation ID, that becomes the function name of the library call. So this will create a get products function that, passes in limits and offsets and deals with, creates the parameters in Python or Ruby or whatever code you're programmatically generating to be able to get you that same general product object in a consistent way. You have to specify some response objects. So, if a 200 response is a good one, then it comes in with a application JSON header, and you can parse that JSON blob using this schema, which is referred to previously in the document. Here's an example of a post, create a product, right? It's pretty simple. You specify request body, and then point it to the schema again, and you have a lot of the same fields there as well. And note you're using post up here. Here's like a get a single item, right? Same deal. You can pass in curly brace here, product ID, and then you can specify, I think this should actually be in:path. In:path, name, product ID, and the schema, and you can ref to a particular point, but in practice, most IDs are just strings. So this returns a product object. Here's a delete. Pretty straightforward. Okay, so you've built this spec file, all the different endpoints. How do you actually use it? Well, you can, first thing that we do is we use a tool called Spectral to lint our YAML because we want to find gaps in it. These tools don't work well when the stuff you put in them is garbage. And I make a lot of typos, so I make a lot of garbage. And OpenAPI, then you just call it the generator CLI. You pass in a generator type, so in this case Ruby. You pass in a codegen config file, API YAML. We'll get into that in a second. You pass in this is the API JSON schema input. The C is the config file. The O is the output directory that it gets built to. Okay, and it's as simple as that, but there's actually a lot more than you can do than just building client libraries. You can also, for example, integrate on tools like Rapid API and Postman by taking that same specification file and just uploading it into those platforms. They can build out tools that they can give to their customers to help them work with you, right? So if you're building a new API and you want to get on Postman, you just send them a file, right? That's awesome. Retool, for example, has an integration with us where you can go and use their no-code, low-code tool, and they call our APIs, and all we had to do to set this up was send them an email with our file. That was it. And they wanted to. Retool really wants this. They want to connect with more and more kinds of APIs to build the value of their product. And they're not just client generators, but you can also generate servers. In fact, at the moment, we're looking at generating our own API server from that spec file. You can also generate documentation. K6 is a tool, it's kind of a load testing tool that you can use that same spec file and then say, okay, well, if I know all my endpoints, I can do load testing with that. Apache config, I mean, if you have your endpoints listed out, then you don't really need to go too deep into the specifics of Apache config. You can programmatically generate a bunch of the components yourself. And of course, the schema generators, which enables, like Avro is a thrift schema, the GraphQL schema, MySQL schema. So you can take from this OpenAPI specification format and convert it into other formats too. So in reality, it's a lot like a compiler, basically. You take, it's kind of a transpiler. You take some, your OpenAPI spec file is a kind of intermediate representation of an API, and then from that, you can do whatever you want once you have that kind of in your code. And so one thing, obviously we talked about generating a library. This is a Ruby one as an example. And you come up with some config parameters, which are listed here, mostly specific around Ruby, right? What are the gem details, what are the author, and kind of metadata. And then it just magically generates the Ruby for you. So you get model objects, you get the client libraries, you can get the server stub, you get the associated documentation. But that's not all you can do. It's not just Ruby, right? You can do all sorts of things. So if I wanted to do TypeScript, for example, just write this little bit of config specific to TypeScript, and then generate it. And so all the work that I did to make that first library work, the second library took 10 minutes, right? Ballpark. Magic. Okay, so when we did this project, we broke it down into phases. The first phase was kind of the 2 libraries approach. So we wanted to build out the infrastructure that let us build and update and keep all this stuff going. And we started with just 2 SDKs, Ruby and Node, right? And the idea being that like 2 is enough to where we have to think about we're going to do multiple of these, so we have to build systems that are, work that way. But not too many that we bog ourselves down. So we decided let's start with 2, Ruby and Node. They're very easy, they're very forgiving, right? The templates are very mature. They've had a lot of work done on them already in the project itself. But it wasn't all, rainbows and unicorns. There were some problems, right, with phase 1. There was some existing third-party libraries that we had, customers of ours who were very passionate about using us, and they built their own third-party library. So I was like, okay, well, now that I've built a Ruby gem, I got to go out there and find the existing Ruby gems and be like, actually, your out-of-date thing isn't, as useful as it was, and so we'd like to be able to take ownership of that. So we worked a lot, actually, with the community to find those third-party libraries and take ownership of them. The other challenge was just keeping that YAML file as a source of truth. So we have our product engineers keep building new API endpoints. They don't remember to update the schema, right? So we had to figure out, okay, how do we work together as a company a little bit, right? The other thing is that some of the more recent OpenAPI specification features in 3.0 plus in particular don't work in OpenAPI Generator. So the project, the OpenAPI Generator project, it's not, it still gets work done on it and it's being maintained, but it's not like a, consistently kept up to date all the time. When there has been upstream changes to languages, it doesn't magically, there's no team anywhere magically making that happen. Someone has to go build a template, submit it upstream, because the core development team is like 3 people, really. And they're not, I think one lives off of essentially open source donations. So there's a limit to the amount of coverage that you can reasonably expect, and this was one gap that we found. There's also a lot of template boilerplate, things that OpenAPI Generator puts in templates to be helpful that we didn't find were super helpful and just, had to cut out. Authentication scheme was another tricky thing. Like we have a lot of tech debt in our API. Auth schemes is one. We have like a weird authentication system. I don't know if you guys know, Ruby on Rails has this like API, like it magically makes an API for you, but it doesn't really quite work. It's not really REST specific. It doesn't fit the REST specification. So there's like post and put don't really work as you would expect. Authentication is another weird one. And the other one was user agent headers, right? We wanted to be able to track when people were using these APIs, and the existing systems in place don't make it easy to, add those user agent headers to the system. And so the next thing we did was phase 2, which was strong type SDKs after we did that phase 1 of Ruby and Node. And the idea here being, okay, well, we've got the Ruby and the Node in. It helps us make sure that it's working, but it's all weak type systems. Like there are problems in our spec file that are not correct because our tests only, Ruby is very forgiving for better or for worse. Node is very forgiving for better or for worse. And so we wanted to really amp up the quality once we had that kind of core infrastructure in place. And so we started doing Java, C++, C#, Rust, and Go with kind of more strong typed SDKs. Actually, C#, and Rust were the 2 that really pushed our, helped smoke out a lot of the problems in our specification and the typing system that we had. So that was a super helpful exercise for us, and we did a huge amount of updates to the spec file that we didn't do in the TypeScript one, right? So you do the Ruby one, the TypeScript one, you didn't need to change the spec file, but then when you layer in C++ and C# and these strong type languages, then you have to go in and actually double check that stuff. And then after that, we did, these, by the way, these 3 phases, the 2 languages was like a year ago. The phase 2 was maybe 6 months ago. And phase 2 took us like, probably like 5-6 months, probably about a month each, essentially. But by the time we got to phase 3, we worked out all those weird little nuance issues in our spec, and we built up a system and a rig that was mature and robust. Python only took 1 week. And actually, it was 1 day and then of like writing the code, and then 4 days of writing the test code. Because eventually our rig was built out where we had tests for every single endpoint. So it was actually like, okay, we need to test out the Python, which was great for us. We could experience in kind of a test-driven development-like way, we could write out the test and experience what it's like to be a caller and find those weird gaps in what people expect and what the generator outputs. We didn't fix all those gaps, but at least we took note of them. We figured out what they were. PHP, we just gave it to an intern who joined us for the summer, and they were able to look at the code, and we had like a fairly well carved out path for adding a new language at that point. And so they were able to just very quickly put something together. So like they were like, this is an 8-week intern project where they had to learn Java, they had to learn PHP, they had to learn OpenAPI generator, they had to learn our API endpoints, and they had to write 38 endpoints worth of tests. And they did all of that actually in 6 weeks, not 8 weeks. But we polished and made them do documentation and other stuff, and we had a couple parties, so we stretched it out to an 8-week internship. But it was, the point is that once you've built out this system, and you've gotten past a few different languages, if you're using this technique, those new languages are very effortless. And as you update the API endpoints, the updates to those other languages, to those downstream libraries, are actually extremely quick. And that was the goal, right? We want to be able to do that. And so looking forward, what we're thinking about is we have an API mock server. And so this is a programmatically generated mock server that makes it so that when we run our continuous integration tests, we're not hitting the live API all the time, right? So that's good. And it's also potentially serving as the base for our next generation API server, right? So we're able to kind of, make this spec file the single source of truth slowly by building out these libraries and then kind of, pushing tentacles into our API server, into our client-side SDKs, right? Because, our model, our core products business logic model includes things like products and notifications and users and, outcomes and other kinds of general primitives that should be the same everywhere. And so the more that we can, programmatically invalidate and ensure that they're the same everywhere, the better off we'll be to prevent risk and eliminate the kinds of bugs that you get when you have a drift, because this caller is moving forward and the server is moving forward, but they're kind of moving forward away from each other a little bit in ways that can build up over time. Another thing we want to do is add a high-level semantic API. So the API client library generation, really it's just functions, right? It's get product, view product, delete product, right? Create product. There's not a higher level construct where you can be like, well, I want to send an email to a user, which actually means I have to create a user, and then I have to create a notification object, and then I have to associate the user with a segment, and then create a notification. So it's like multiple calls. So there's a higher level semantic API we want to be able to provide in all these different languages that stitches together the different ways that people call those endpoints, right? Because a RESTful API, the idea is that you have a resource, it's generic, you can just act on it in different ways. But the reality is that when you put everything in that bucket, this is kind of like a major difference between RESTful APIs and RPC APIs. When you put everything in that bucket, you lose some amount of when you're working with a user object, you have to kind of work with it this way. You have to build out you have to, call the APIs in these orders, right, to make them work. Some of that semantics is lost if it's just a list of functions. And so we want to create a higher level semantic API on top of that. It's kind of something we're looking to do. I'll get to QA in a second. I want to actually walk you through the code. This is not open source yet. We would like to open source it. The risk essentially is we have tokens in the Git history that I have to scrub. I'll get around to it. But let me walk you through this. I don't know how well you can kind of see it here. Okay, a little bit. So this is the README file. So we run script build, which is a script that we kind of created to wrap around it and just pass in the specific languages you want to build. And then we have this kind of script test. And this is the interesting bit here. So the layout of our repo here, we have the inputs, which has 4 inputs, the API spec itself, right? CodeGen, which is all those YAML files, the OpenAPI generator project, which we actually have a fork of because we had to make all those changes to it, and not all of those are upstreamable. And then static, right? So these are static files we add afterwards, like README Markdown, or maybe when we want to create those higher level semantic APIs, we'll probably do that in using a static overlay. And then of course the outputs. And this uses, we use Git subtrees to link the repos together. So this is the map of all the different subtrees. So these are all mapped together in subtrees. And there's quite a bit of documentation here on how to add new stuff. I'm not going to go into that too much. Like server, builder, okay. So let me show you. Okay. I want to show you the GitHub. I want to show you the inputs, some of the scripts. Actually, I should show you test also. Okay, so the first thing I'll show you is the inputs. So we have, like I said, there's 4 inputs, the API spec file, CodeGen, YAML files. Here are all the different YAMLs. So here's like PHP, for example, PHP specific stuff. And then static. So we have all, so this goes into everything. That includes things like license files, issue templates, pull request templates. And then the language specific stuff, like here's TypeScript, for example, which has maybe a change log and release instructions and some GitHub workflows to do an npm deploy. So there's a GitHub action that does an npm deploy for us. Now let me show you the other GitHub actions. So this is a whole kind of like graph of GitHub actions that we have built out to cascade and automate the system. And at the highest level, it works off of these 3, CI, which is basically per PR testing, right, as you can expect. CD, now this is the interesting bit. So when a change actually gets pushed, so a pull request is merged in, we will, quote unquote, continuously deliver by submitting PRs to the repos. So we actually have to go through some setup steps, and then bootstrap dependencies, blah, 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 blah. And then we build everything, and then we check out language by language. We do a checkout of the repo, the API client repo. Then we patch it using the changes. And this bit deals with the fact that it's kind of hard to, you can't git patch or deletion. So there's a little bit of code you have to deal with here to deal with like git patching deletion. And then we just push it. We push to a specific branch, which we designate the API branch as being the one where the upstream changes are received. And then we submit a PR using the OctoKit API. And so let me show you what that looks like. So at this submit downstream, so I updated the README earlier today. And so this calls dist. Okay, and so what this did was it like checked out the Ruby and set up the job, and literally, this is run the setup. Okay, so here's Ruby. So it checks it out, and then does the patch, does the push, and submits a PR. And this basically says validation failed, in part because the change that was being made here doesn't affect the downstream code. It was just to the README. But there are plenty of cases where that downstream code comes into play. So let me pull up the linked Ruby repo. And these clients are actually public, so you can see these, and I'll get that higher level one made public. Pull requests, look at the closed PRs. And you'll see this dependency update merged yesterday. And so literally it just puts WIP work in progress for the description. We should update that. but it programmatically updates. So we removed ID from player. It wasn't strictly required. And so this automatically updated the Ruby documentation. I guess this is another typo we fixed. At the high level, then the specific like player model object documentation, as well as the player model object itself. So I think we took ID out, so it just takes it out. And so this same pull request exists. Let's pull up the C++ one, see if we can find that one. CPP-API, I think. No. I guess this is the only bit that cascaded down. But essentially, what it'll do is it'll cascade down those different PR sends to the 10 different client libraries based off of the change. And then the third thing is a dependency update. So we have the workflow that does the test on new PRs, the workflow that does the submit downstream pushes on PRs. Then in each of those downstream repos, when those PRs are applied, we deploy to the package store like NPM or I forget what it is for Java. And then the last thing we have is this depths thing. And what this does actually is it rebases on a I guess this is nightly, rebases nightly all the dependencies. So all those inputs, they get fetched in nightly. So when we have an upstream fix to the node OpenAPI generator template because dependent bot, whatever, left pad had a bug in it, who knows. It just automatically will create the PR here. We manually review it, make sure it looks good, and then we submit it, and then it'll automatically create the PR for node, and we just manually validate that, make sure it looks good, and then we submit it, and it automatically goes to the package store. And so the level of effort here is extremely small. And most of the time, all you really need to do is, let me show you something in Ruby, these test functions. And so we are able to narrow down the effort involved with keeping these things up to date to be basically, validating that the tests are being called correctly in each language and keeping it narrowly focused on the things that are important. And the part of the way we do that is this huge scripts collection, which deals with all the different nuances. So like, here's how to run Java tests. Oh, we have Maven tests. That's not bad at all. Here's the build script for an example. So build is like an outer wrapper. It takes all the inputs. And then just runs Docker build to create a new container, and then running in that Docker the Maven install. So this builds the OpenAPI generator itself, and then you actually run it here to run generate. And then we copy the static stuff over, and then we run a language specific, and then we build that kind of Git output of things, files that were removed. Right? I think I mentioned that earlier. And that's basically all that was required to set up this infrastructure that enables us to have, highly idiomatic, consistently up-to-date, large SDK spread without requiring too much effort. So that's all the content I prepared. If you have any specific questions, I'd be happy to talk about that. I know folks may have thoughts or perspectives. Generally, the alternative to this approach is writing it all yourself from scratch. And in terms of like the effort involved, in like what you get out of it here, this technique of programmatically generating specifically for API client libraries, for other things it becomes a little more complicated, but specifically for API client libraries, is kind of a no-brainer. And I see a lot of organizations, engineering teams looking at, oh, we need to do this, and they're like, okay, well, we can't do 10 of them, let's do one, and start with one, and then they build one by hand, and by the time they're done, I've built 10. And so as much as you can, as you're building products, think about ways that you can leverage these techniques to improve your productivity and maximize your impact. You're going to stand out, not just as an individual, but as a company and as a team. And those are really, really important. So hopefully that was helpful. Any questions, thoughts? Yep. It's just you, man. Okay, oh, wait, the mic, yeah.
I would like to know if when the library gets generated, it is dependency free or it includes its dependencies with it.
Yeah, so let me walk you through the OpenAPI generator code base a little bit. Because I think that will help clarify. So inside the OpenAPI generator, you will find lots and lots of languages. I gotta go up here. View code. So there is, I think it's modules, OpenAPI generator, source, main. I'm getting very Java here. No, it's not this. Okay. So this one, the resources, these are all the different generator template files. And so I'll pull up like JavaScript because that one has just a buttload of dependencies. I'll take TypeScript-node. And these will come with mustache files. And so this is like the API file. This is like a single API. So this is like a partial, essentially. And there should be, there's a ts config. Oh, there's no package.
Yeah, at the bottom.
Package.mustache, this is what I'm looking for. And so this is all the dependencies. So this is the dependencies the template requires. So in my fork, I might change some stuff, move some stuff around. I don't feel like I need all of these things, for example. Maybe I have more things I want, you know. But it is baked into the template. Like license, unlicensed, you know, like I can't do that. But it works for the template, for the general purpose, and then we tweak it in the forks.
Okay, so like it comes with its implementation to anything related to the language. So, because I saw that you presented Dart there, and you know that actually I haven't seen any use for Dart besides Flutter. So it comes with its implementation.
Yeah, I mean Dart's. I agree with you that I haven't seen a whole lot of use for Dart outside of Flutter, but that's not how the Dart community feels. And so they, you know, I don't even know. PubSpec is like their version of package. So they built this thing, and you can see this doesn't actually depend on Flutter. So this is not Flutter specific. This package will probably work on Flutter, right? The JavaScript one will probably work on React Native. The Java one will probably work on Android. The Swift one will almost certainly work on iOS. But you know, it is, for us, the client-side SDKs weren't really important. We already had some of that stuff. And the other thing is, for us, our client SDKs aren't just API callers. They do a lot of stuff. Like we have like UI components in there. We have a web view that you can trigger. So that, you know, that kind of higher, anything beyond just network calls, API network calls, right? This system isn't going to really be built, you know, system as it's currently implemented isn't going to work well for. You can, like, programmatically generate an API client library, which is just, oh, here's 40 API functions, and then add on top of it, you know, more semantic stuff, which is something we want to do on the server side. We would have to do it client side in our case, because like you can't do push notifications in Flutter with just API calls, right? You have to do Flutter calls, you have to do system calls to the kernel and other stuff. I don't know if that answers your question.
That's it.
Cool. Yep.
You mentioned briefly high-level scenarios that are a composition of row calls, like create a user here, then send an email, and so on and so forth. Have you looked at the workflows special interest group under OpenAPI? Because this is something that the community is working on, to have some definition language to describe workflows that need to be either sequenced or parallelized, or if you have, you know, like decision trees or stuff like that to implement. And some generators, I'm not saying which ones, might be able to, you know, it's already generating the code for the roll calls. So now we might be able also to generate on top of that the code for the scenario that calls call 1, call 2, call 3, and so on and so forth, right?
Yeah, that is an interesting point. You know, OpenAPI Community is constantly evolving this stuff, right? So the OpenAPI Foundation under the OpenAPI Initiative, they have special interest groups like Vincent mentioned, and those special interest groups, you know, help advance the specification forward in different ways. I will probably, you know, after you've mentioned that, I will probably reach out to those special interest groups and start having those conversations, because we have enough experience now to be additive, to provide real value, whereas before it would just be asking questions, right? We still haven't got a full grasp around it. But I think there is room to improve this. Like, it should be possible for the OpenAPI Spec to model out at least some of these higher level kind of semantic things. You call it the workflow one, it's a fairly common one. Some of them you can't. You'll never really be able to model a generic, you know, a thing in a function like that in a YAML block. At a certain point, it's like, well, you know, you just you know, you might as well write code, right, and import it in. And so, you know, I don't know that OpenAPI itself would ever want to do that. Maybe a specific generator would want to do that. So I think that this is a solution that can come in part from changes to the OpenAPI specification format itself, but some of that will not be solvable in that way. And I think the generator specifically. So I mentioned OpenAPI generator, Swagger, CodeGen, and Kyoto. There are probably others. You may know of others. But those are, you know, Kyoto's relatively new. Swagger, CodeGen, and OpenAPI Generator are basically the same code base. There was a fork. And it's quite robust and mature, but it has a lot of gaps. And so I don't, you know, I would be curious to see how this space evolves. I think as an industry, more and more people are realizing, especially what's happening now is microservices. And people in these big companies, you know, can now, you know, teams can now pick their own language. So it used to be that, like, you know, if a company passed a certain size, you immediately set a policy. Here are the 5 code languages we do. Everything outside of these 5 requires special approval, right, for special reasons, okay? But these are the 5 we do. We're Java, Python, and whatever, Go shop. And if it doesn't, you know, if it can't be done in Java, Python, or Go, you need to have VP approval to do it, right? That used to be standard practice. And then with the whole microservices, distributed ownership within teams, distributed service boundaries, so you weren't sharing code between systems, we found that, I have found, that there's a lot of languages like Scala, right? That before it was like, Scala, you're either a Scala shop or you're not. Now it's like, oh, you know, yeah, we have 1 or 2 functions in Scala, and those need to call out to some vendor, right? So I think increasingly API developers, people who build network APIs for people to call against, are finding that the number of languages that they need to think about when they're building APIs is increasing. And so I suspect that tools like OpenAPI Generator, I mean, look at the numbers of, you know, different ones they have here. This is on the order of, you know, 80, right? 80 to 100. And some of these are just different kinds of Java. But I think that there will be a lot more interest in developing this general technique. You know, I think, like, here are some of the companies that sponsor OpenAPI Generator, for example. And some of these, you know, some of these organizations, like, they did not start by using this tool. They started by going their own way. They roll it themselves, and they realized, I'm paying 10 people to write the same code 10 times, when I could be paying 1 person to write the code 1 time. And that kind of O of N factor that, like, you know, is being compressed down to O of 1. All these things that used to take, I have to support this API for as many languages as there are. Now I just have to support the API building system, which incrementally increases with the number of languages. And as the number of languages increases, more and more people are reaching towards tools like these. And I think that we will see an increase in the amount of conversation and investment in tools. At least I hope so. I mean, certainly, I know you've worked on Kyoto, right? And so that's a Microsoft-sponsored thing. I fully expect that there will be more tools like this built, you know, being started today. There are probably new projects just like this one being started today from scratch with new ideas, new thoughts, new lessons, new learnings. because this isn't new. OpenAPI Generator is, newish in the sense that it was built about 15 years ago. But like, we were doing things like this 15 years before. It was just a different, it was like what, WSDL generators or whatever, right? Like, some of these techniques evolve and we build out infrastructure and then we say, okay, well, we learned a lot in the past 5 years and we want to get rid of all this legacy infrastructure and build something new from scratch now that the problem is more well understood. And so I think we're actually in this phase here, and that's part of the reason I'm talking about this. Because I think that the more as a community that we can use techniques and tools like this, the more that we'll collectively invest in making it better, and will enable people to focus on building the parts of the software that are important to them. Because I don't want to have to write another Python API client library that's like, take this API stuff, write it out. It just seems like it's like CRUD scaffolding, right? Like it's so not a good use of my time, right? And it's like, okay, well, I can work with people who are newer to the field and give it to them, but it's like, why would I, it's not a good use of even a junior engineering time if you're not really learning anything of value, you're not maximizing your impact. So.
Thank you very much.
Thank you. Any other questions? Comments? Concerns? Okay, cool. Well, we will close up a little early, 10 minutes early. So thank you so much. It was great chatting with you all here today.